All right, this is problem number 4 from our sample problems. All right. By the way, so this is what I'm, this is what I'm working on. These these sample problems. Okay, from chapters 6, 7, and 8. Okay, so there are. Let's see. Um, so there's 16 of them. There's a formula sheet as well to help us with the test. Okay, so those are we'll do all these examples. All right, so right now we are on number 4. All right, so let's go back to this and actually solve the problem. Just to show you, I just wanted to show you where that is coming from. I put it on Blackboard. All right, so all right, so to calculate density, of course, here we go. The density is the mass divided by the volume, and the volume of any spherical object is, as large things in astronomy that are, that have enough mass to self gravitate into spheres. Like for example, the asteroids are not quite big enough. Most of the asteroids are not quite big enough to be a perfect sphere, because there's not enough mass for that to happen. But moons and most moons, I should say, and of course planets always self gravitate into a sphere. So the volume of any sphere is 4 times pi divided by 3 times the radius of the sphere to the third power, and r has to be in centimeters. All right, so that when we cube it, we're in centimeters cubed. Now, so you can notice right away the radius of the moon is not in centimeters. So let's change that. All right, so r here is 1737.4, all right, kilometers. And then you just play this game as we usually do. 1 kilometer is 10 to the third meters. And now the kilometers cancel, but we don't want to be in meters. We want to be in centimeters. So 1 meter is, of course, 10 to the second centimeters. All right, so the meters cancel. So it's really 1,737.4 times 10 to the fifth. All right, so I'm going to plug that in here. Here, let's actually do this. So it's going to be 4 times pi divided by 3 times 1737.4 times 10 to the fifth centimeters, and then we raise that to the third power. All right, and then of course, and the mass is in kilograms here. So so we need the mass to be in grams, but that's actually pretty easy to do. So here, let me do that as well. All right, so the mass, I'll do that right here. So the mass is of the moon is 7.35 times 10 to the 22nd kilograms, and of course 1 kilogram is 10 to the third grams, 1,000 grams, right? So this is, all right, anyhow, the kilograms cancel, and so 10 to the 22nd and 10 to the third, you just add the two, right? So that becomes, of course, 7.35 times 10 to the 25th grams. All right, so that's what we're going to use. We still have to figure out what the volume is. All right, so I'm gonna do that with my calculator, and then I'm gonna take this number of grams, that's going to go up here, and then divide by the number I'm about to calculate into my calculator. This is the calculation. All right, so here we go. Let me move this down just a little bit. Oops, not like that. Anyhow, here, we'll move it. Oh, goodness, not like that. Sorry. All right, so here we go. All right, so I'm going to do the cube part first. So 1737.4. So you should try this in your calculator. Make sure you know how to do it. Times 10 to the fifth. All right, so now I have to cube that. So for this calculator to raise something to the power, so I hit this X to the Y button, and I raise it to the third power, and so that's going to cube it. I could figure out what that cubed is, but then I'm going to have to multiply it times. I could multiply it right now by 4 pi divided by 3. That's fine. Or here this is what it is cubed. All right, and then times 4 times pi divided by 3. All right, so this is this enormous volume. Your calculator probably would put that in scientific notation. And so just as a reminder that your calculator always remembers the last entry. So I'm going to actually store that here. So this is going to be add to memory. All right, so that's there now. Here, watch. When I clear it, I can do memory recall there. All right, so there's the number. All right, so now I'm going to take this number, which is 7.35, right, times 10 to the 25th, 10 to the 25th, all right, and then divided by the memory recall, which is right there, all right, and so that gives me the density of the moon, all right, and it says, if you notice right here, it says to round one place past the decimal. So the answer is 3.3, right? That's exactly the density of our moon, right? So the answer turns out to be 3.3 grams per centimeter cubed. Right? So remember, this is the numerical value that you wanted to get. All right, let's do number 5. All right, so here's problem number 5. It's actually a two-part. So what we're basically going to do is we're going to use the two moons of Mars, Phobos and Deimos. Remember, Phobos is the larger one, and is getting a little closer to Mars as time goes on, and will eventually crash into the atmosphere. Deimos is the smaller one, probably a captured asteroid, and it's actually moving further away from Mars as time goes by. All right, so anyhow, we have the orbital information. All right, so they give us the semi-major axis. That's the average distance that Phobos. So we'll start with Phobos. So this is the average distance Phobos is away from Mars, 9,377 kilometers, and the period is 7.66 hours. All right. Deimos, of course, which is a little further, has a much bigger semi-major axis, 23,460 kilometers, with a period of 30.35 hours. All right, so we're going to use both of those to figure out the mass of Mars, right? Because that's all the information you need. Just as a reminder, here's what we're going to use, right? Mass is going to equal 4 pi squared. This is, of course, the modified version of Kepler's third law. R to the third, where R is the distance that the satellite, or whatever is orbiting, the distance from the center of the main mass M, where the main mass is, of course, going to be Mars here, divided by G, divided by the period squared. Remember, R has to be in meters. Excuse me, and then the period has to be in the period P period, I don't know why I'm writing period, is supposed to be in seconds. All right, so this has to be in meters. All right, so we'll work with Phobos first, right? So R is, well, I mean it's actually pretty simple. So 9,377 kilometers. Of course, in 1 kilometer there are 10 to the third meters. 1 kilometer, right? The kilometers cancel. All right, so it's just 9,377 times 10 to the third. All right, so here let me rewrite it just for the heck of it. 9,377 e to the third meters. All right, so that's what we're going to use for R. Now the period, it takes a little bit more work here. So the period is 7.66 hours. All right, so hours. And of course, in 1 hour, there's 60 minutes. Use MIN for minutes because it distinguishes it from meter. Is 60 minutes is 1 hour. The hours cancel. And then you say, of course, there's 60 seconds in 1 minute. All right, so the minutes cancel. All right, so it's just 7.66 times 60 squared. All right, so here, let's get our calculator out, and we'll do that. I guess I should move this a little bit. I'll move it right here. All right, so you can see that. All right, so it's oops, still have the last problem on there. All right, so 7.66 times 60 times 60 again, or times 60 squared. All right, equals. All right, so it's 27,576 seconds. All right, so that's going to go here in the denominator, and of course I'm going to have to square that. All right, so all right, so anyhow, I'm going to here, let me store that. All right, in my calculator, because I'm going to need that later. And let's make sure that it was stored. Memory recall. Yeah, there it is. All right, so don't remember, we're going to have to square that in a little bit. All right, so this is 9. So here, let me just type it in. 9,377. Right, so that's the distance Phobos is from the center of Phobos to the center of Mars, times 10 to the third, right? I could just put 3 more zeros, or 10 to the third. All right, now, so it says once it's in meters, I've got to cube that, all right? So I use this x to the y button, and then raised to the third power, and then I multiply by 4 pi squared. So right here, well, this is it to the third power. All right, and then times 4 times pi squared. All right, and then we divide by big G. Just as a reminder, big G is 6.6 times 10 to the minus 11th. So divided by 6.67 times 10 to the minus 11th. All right, so now that's this part. All right, that's this part of the calculation, or what I'm about to do. Once I hit equals, that'll be that part of the calculation, and then I have to divide by the period squared. All right, so this is equals. All right, but I'm not done. Right, I still have to divide by the period squared. All right, divided by. Remember, I saved the period, so I hit this memory recall. Sorry, memory recall. And then, of course, I've got to square the period. Okay, so the period squared equals. All right, and so that is the, yeah, this isn't